name is NV Krishna Rao, Assistant Professor, CSE Department. So in the last class, we have discussed the deterministic finite automata with definition and one example. So we'll discuss the continuation with one more example, how to construct the transition diagram, transition table, example strings, and 5-tuple notation for another example, right? So today we are going to discuss deterministic finite automata example, right? So already we have discussed this 5-tuple notation. So what are the 5-tuple notation? A set of states, right? An alphabet, transition function, and initial state, and a set of final state. So deterministic finite automata always says that each state on each input symbol should give only one and only one output transition, right? So in the last class we discussed one example. So in the last class we discussed a DFA accepting having two consecutive zeros, right? So these are which are the strings accepted or not. Now we'll discuss the construction of DFA for accepting strings ending with two zeros, right? Constructing DFA for accepting strings ending with two zeros, right? So first we'll see which strings are ending with two zeros, which are not. 1, 2 zeros. So it is acceptable. 11, 2 zeros, acceptable. 101, 2 zeros, it's acceptable, right? Then if we consider 1001, 1001, here 2 zeros at the middle, which says that it containing 2 zeros but not ending. If we consider this string, 2 zeros in the middle but 2 zeros at the end also. So this is acceptable, but this is not acceptable. Here it is acceptable, right? Here 2 zeros in the middle of the string. So it is not acceptable. 2 zeros, 101. This also be not acceptable. Now we have seen which strings are acceptable for our regular language, which strings are not acceptable by our condition, right? Now we have to construct a deterministic finite automata which accepts strings ending with two zeros. So what is a regular language? It is a language consists of a group of strings which accepted by a finite automata, right? Now we will see the construction of the finite automata, right? So now we have to construct a DFA, right, ending with two zeros, which consists all the strings X. It should end with, right, two zeros, right? Now we have to represent 5-tuple notation. So what is a 5-tuple notation? M equal to a set of states, input alphabet, transition function, initial state, a set of final state. Okay, that is the 5-tuple notation we have to find. And transition table, transition diagram, and one example string for acceptance, one example string for not acceptance. First step. Now, what is the condition? It should end with two zeros. End with two zeros, right? Then, so initially we take Q0 as the initial state. How to represent the initial state? Placing an arrow. So we are placing an arrow to represent Q0. So Q naught is the initial state. On 0, it is a condition, goes to Q1 state. Right? It goes to Q1 state. Then on another 0, it goes to QF state. Here, our condition is that ending with 2 zeros. So, we are represented our conditions, right? Now, so we consider this QF as the final state, right? The QF as final state. QF as final state. DFA state, what the DFA says, each state and each input symbol should have one and only one transitions. So we have considered our condition transactions. That is, 2 zeros should be there. We have considered. Now we have to find what are the remaining transitions. What are the remaining transitions? Now Q naught on 1, where it goes, we have to find. Q naught on 1, where it goes, we have to find. Q naught on 0, already we know that it is 0. Right? Right? Q naught on 0, we know that it is Q1. Now, Q naught on 1, where it goes, we have to find. Then, Q1 on 0, we know that it is the QF. But, what is the Q1 on G1? We have to find out. Right? So, we are specifying what transitions we have, what transitions we have to assume. Right? Then, we need also find QF on 0, and also we have to find QF on 1. What should be these transitions? Right? Here, Q naught on 1, we have to find. Right? 1 is the prefix of our condition, is prefix of our condition 2 zeros? No. Is 1 is prefix of our condition 2 zeros? No. So, after 1, it should follow 2 zeros to reach the final state. From which state? Now, consider what is the meaning here. Which state on 2 zeros will reach the final state? By default, it is Q naught. So, it is Q naught. So, what is giving here? If we consider this assumption, Q naught on 1 goes to Q naught. Now, we have to find Q naught on 1, where it goes. We have to find the transition. But, 1 is the prefix of 2 zeros? No. So, after 1, there should be 2 zeros to reach the final state. After 1, there must be 2 zeros to reach the final state. After 1, there must be 2 zeros to reach the final state. Now, from which state on 2 zeros reaches the final state? Indirectly, it is Q naught. So, that is the Q naught state. So, now consider Q naught on 1 goes to Q naught. Q naught on 1 goes to Q naught. Right? Q naught on 1 goes to Q naught. Right? And then, what it implying? Q naught on 1, Q naught. So, we have considered our transition Q naught on 1 goes to Q naught. So that it will follow the 2 zeros to reach the final state. Right? Our assumption is completed. Now, another one. Q1 on 1, where it goes. We have to find the Q1 on 0 is QF. We got the transition. But Q1 on 1, where it goes, we have to find. But how we reach the Q1? How we reach Q naught on 0 goes to Q1. Q1 on 1, where it has to go. We have to find. Now, 0, 1 is prefix of 0, 0? No. 1 is prefix of 0, 0? No. What it implying? After 1, it must follow two zeros to reach QF. It must, after 1, it must follow two zeros to reach the final state. Right. So, here we need 2 zeros to reach final state. Now, here consider this part. What it implying? Which state on 2 zeros reach the final state? Which state on 2 zeros to reach the final state? That is Q0. Q0 is a state on 2 zeros reaches the final state. Right? Now, so what is implying here? It is implying Q1 on 1 goes to Q0. Q1 on 1 goes to Q0. Is it clear? Q1 on 1 goes to Q0. Q1 on 1 goes to Q0. So, we found the another transition also. Now, QF on 0 we have to find. Right? QF on 0 we have to find. QF. Now, how we reach the final state? Q0 on 0, Q1, Q1 on 0, QF, QF on 0, we have to find. Which implies 3 zeros. Last 2 are 2 zeros. Means simply final state. Simply a final state. QF on 0 goes to QF only. Because how is reaching the final state? Following 2 zeros. Then how to find now? How to find which transition? QF on 0. What is it implying? 3 zeros. 3 zeros indirectly meaning that it is accepting the string. It is in the correct condition. So the string is accepting the condition. So it's simply QF. Right? Simply it is QF. Right? So simply we say that it is in the final state only. So simply we can conclude. Simply we can conclude here QF on 0 goes to QF only. Right? So simply we have written QF on 0 goes to QF. Now we have to find QF on 1. We have to find QF on 1. Then how to reach? How we are reaching the QF? Q0 on 0, it's a Q1. Q1 on 0, it's a QF. QF on 1 we have to find. So what here implying 0, 0, 1 is prefix of 0, 0? No. 0, 1 is prefix of 0, 0? No. At least 1 is prefix of 0, 0? No. Right? So, what it implying? After 1, it must follow 2 zeros. After 1, it must follow 2 zeros. So, it must follow 2 zeros to reach final state. What is the state which follows 2 zeros to reach the final state? Simply, it is a Q0. Q0 is a state on 2 zeros reaches the final state. So what is here implying? QF on 1 goes to Q0. QF on 1 goes to Q0. Right? QF on 1 goes to Q0. That is a transition. So what is the transitions? QF on 1 goes to Q0. So here QF on 1. QF on 1 goes to Q0. So this is our completed transition diagram. So this is the transition diagram. Right? Now, we represent 5 tuple notation. What are the set of states? Q0, Q1, QF. That are the set of states. Is it clear? Then, what is the input alphabet? 0, 1. What is the initial state Q0? It is Q0 only. Then, what is the final states? What are the final state? A set of states, that is QF. Okay, is it clear? Then, what are the transitions? Q0 on 0 goes to Q1. Q0 on 1 goes to Q0 only. Q1 on 0 goes to QF. Q1 on 1 goes to Q0. QF on 0 goes to QF only. But QF on 1 goes to Q0. So that is the transition. We have represented in 5 tuple notation. Now, what is a transition table? Transition table which consists rows and columns. The columns are represented by the input symbols, and you use the delta to represent the table as a transition function. Then the rows are represented. Q0 is the initial state with arrow as a preceding. Then Q1 is another row and QF. How to represent final state? Either we circle the QF or we'll place star. The star indicate QF is a final state. Now Q0 on 0, where it goes? Q1. Q0 on 1, it is Q0. Right? Then Q1 on 0, QF. Q1 on 1 goes to Q0. Q1 on 1 goes to Q0. Then QF on 0, QF only. QF on 1, it is a Q0. So, we represented the transition table, right? Transition table. We represented the transition table, right? Now, we have to represent one example string for the acceptance, one example string for the not acceptance, right? So, in the previously we have discussed which strings are accepted, which strings are not accepted, right? Now, we know that in general for acceptance, 1, 0, 1, 2 zeros. This is accepted, right? Now we'll check. String transition function, Q0 is the initial state. Our string is 1, 0, 1, 2 zeros. We want to check this string is acceptable or not. Now, first transition function, transition of Q0 on 1, comma 0, 1, 0, 0. Now, Q naught on 1, where it goes? If you refer the transition table, Q naught on 1 is Q naught only. If you refer the transition Q naught on 0, goes to Q1 only. And if you refer the transition diagram, Q naught on 1 is Q naught only. Right? It's a Q naught. Now, we are writing this as Q naught, remaining symbols 0, 1, 2 zeros. Now we are considering Q naught on 0. So, Q naught, transition of Q naught on 0, followed by 1, 2 zeros. Right? So, what is a Q naught on 0? Q naught on 0 from the transition diagram, or from the transitions, or from the transition table. It's simply Q1. Right? So, what it is giving now? String transition function of Q1 is a now current state. So, what are the remaining symbol? 1, 0, 0. Now, what we have to consider? Q1 on 1. So, string transition function, transition of Q1 on 1, we have to find remaining symbols 2 zeros. So, Q1 on 1, where it goes? From the transition diagram, or from the transition table, or from the transitions. From the transition, simply it says Q1 on 1, it's a Q naught. So, what it is giving? String transition function Q naught giving 2 zeros. String transition function Q naught on 0. Now we have to consider Q naught on 0. Right? Transition of Q naught on 0. Right? Now, what is a Q naught on 0? Is once again Q1. So, what it is giving now? String transition function of Q1 on 0. So, what it is giving simply? It will be transition function of Q1 on 0. It is QF, which belongs to final state. So, the string is accepted. The string is accepted. Right? Is it clear? The final output state by reading the symbols of the string 1, 0, 1, 2 zeros will result into the QF. So, since QF is a final state, so the string is accepted. So, now we have considered the string for accepted. Check one more string which is not accepted. We are considering as another input string as 1, 2 zeros, 1. Right? 1, 2 zeros, 1. So, by our definition, it should not accept. But we have to prove that it is accepted or not. Right? Now, we'll check. String transition function. String transition function. Q naught input is 1, 2 zeros, 1. So, we consider the first symbol. So, string transition functions, transition of Q naught on 1 and followed by 2 zeros, 1. Which results here, it is should be Q naught only. Right? Q naught on 1 is Q naught only. So, string transition function remaining Q naught, 2 zeros, 1. Now, we have to consider Q naught, the next input symbol is 0. So, consider string transition function, transition of Q naught on 0, right? Remaining symbols are 0, 1. Right? Now, which is giving? Here Q naught on 0 is Q1. So, string transition 1, Q naught on 0, Q1. So, Q1, remaining symbols 0, 1. So, we have to consider Q1 on 0. Right? We have to consider Q1 on 0. So, string transition function, transition of Q1 on 0, we have to find. So, what is the remaining symbol? It's 0. But Q1 on 0 is giving QF. right? From the transition diagram or from the transition table or from the transactions, same Q1 on 0 going to Qf, right? Now, the string transition function, right? Qf on 1 we have to find. So Qf on 1 is, which is giving Q1, Qf on 1 is simply Q0. The final output of Qf on 1 is Q0, which is not belongs to a set of final state. So, not accepted. So, not accepted. So, the string is not accepted. So, we are proving our assumption is correct by taking one string for acceptance, one string for the not accepted, right? So, here, whenever they are given to construct a deterministic finite automata, we have to draw the transition diagram, transition table, phi tuple notation, then one example string for acceptance, one example string for not accepted, right? So, till now we have seen two examples containing two consecutive zeros. The two zeros might be at the starting or middle or end. Okay, it will be accepted. Now, our second example is ending with two zeros. Ending with two zeros. So, it will be accepted if the two zeros are at the end only. If it is at the beginning, at the middle occurred, then it will not be accepted. Right? So, this is our second example. Now we'll discuss one more example. So, ending with two zeros are over. Right? Now, what is our problem is construct a DFA accepting strings having 0, 1, 0. Now, which strings are acceptable, which are not acceptable, we check. Right? 0, 1, 1, 0. Is it acceptable? No. 1, 0, 1, 0. Acceptable. Here, accepting strings having 0, 1, 0. Also be acceptable. Also be acceptable. Because 0, 1, 0 exists, 0, 1, 0 exists, or 0, 1, 0 exists. At the end, or at the middle, at the beginning, the sequence is there, then it is acceptable. So, 1, 2 zeros, 1, 0, also acceptable because 0, 1, 0 is there. 1, 1, 0, 1, 1, not acceptable. So, we are seeing which strings are acceptable, which strings are not acceptable for this type of problem. Now, we'll see the construction of deterministic finite automata. Now, what is our problem? We have to construct a DFA. It consists of all the strings W such that it will be of form 0, 1, 0, y, where x comma y belongs to 0, 1 star. So, it might be x and y a sequence of zeros and ones. What is our problem? It is a DFA we have to construct. It accepts all the strings of W which is in the form of x, 0, 1, y, 0, y, where x and y are the sequence of zeros and ones. So already we have said which strings are accepted, which strings are not accepted. So now we'll see a transition diagram first. Transition diagram. So initial state we represent as arrow, right? Initial state with arrow with Q0. Then on 0 it goes to Q1. On 1 goes to Q2. On 0 goes to QF. We are representing our condition 0, 1, 0. We are representing our condition 0, 1, 0. right? Q naught on 0, Q1, Q1 on 0, Q2, Q2 on 0, QF, right? Now, we have to find all the remaining transitions. Q naught on 0 goes to Q1, but Q naught on 1, where it goes? Here, 1 is the prefix of 0, 1, 0? No. 1 is the prefix of 0, 1, 0? No. So, it must follow 0, 1, 0 to reach final state. So, either here, this condition resembles that Q naught only on 0, 1, 0 reaches the final state. So, which says that Q naught on 1 goes to Q naught only. Q naught on 1 goes to Q naught only. 1 is not a prefix of our condition string. So, it must follow 0, 1, 0 to reach the final state. So, it must follow the 0, 1, 0 to reach the final state. So, here, which is the state will follow 0, 1, 0 to reach the final state? That is a Q naught. What it implying? Q naught on 1 goes to Q naught. Q naught on 1 goes to Q naught. Right? So, Q naught on 1 goes to Q naught. We have written itself. Right? Then, Q1 on 1 goes to Q1 on 1 goes to Q2. But Q1 on 0, where it goes? How you reach the Q1? Q0 on 0 goes to Q1. 2 zeros is a prefix of 0, 1, 0? No. But 0 is a prefix of 0, 1, 0. So, it must follow 1, 0 to reach the final state. So, after 0, it required only 1, 0 to reach the final state. So, what this condition implies? Which state on 1, 0 reaches the final state? Which state on 1, 0 reach the final state? So, it must be Q1 state. Q1 state on 1, 0 goes to final state. So, here, what this implying? Q1 on 0 goes to Q1 only. Q1 on 0 goes to Q1 only. Right? So, our second transition Q1 on 0 also we have found. Right? Next, Q2 on 0 goes to QF. Right? Q2 on 0 goes to QF. Right? So, we know the transition. Right? Q2 on 0 goes to QF. Then, what is the Q2 on 1? We have to find Q2 on 1, where it goes. How you reach the Q2? How you reach the Q2? Q0 on 0 goes to Q1. Q1 on 1 goes to Q2. Now tell me, 0, 1, 1 is a prefix of condition? No. 0, 1, 1 is prefix of condition 0, 1, 0. No. 1, 1 is a prefix of 0, 1, 0. No. 1 is a prefix of 0, 1, 0. No. So what is the implies? After 1, it must follow 0, 1, 0. It must follow 0, 1, 0. Right? It must follow 0, 1, 0. So, what implied? Q2 on 0, 1, 0 goes to QF. Which state on 0, 1, 0 goes to QF? Q0. Q0 is a state on 0, 1, 0 goes to QF. Now, what this is giving now? Q2 on 1 going to Q0. Q2 on 1 going to Q0. Q2 on 1 going to Q0. Right? That is the our transition. Now QF, final state. QF on 0 we have to find. QF on 1 we have to find. How we reach this QF? Q0 on 0 1 0 going to QF. Q0 on 0 1 0 going to QF. After reaching the final state, after satisfying the condition, means it will be in the final state only. After 0 1 0, either zeros or ones are accepted. X 0 1 0 y. What is a y? A sequence of zeros ones. After the condition 0 1 0, either 0 or 1, both are accepted. So it results the final state only. QF on 1 only also gives the final state only. So QF on 0 1 goes to QF only. Now our transition diagram is completed. Now 5 tuple notation. Right? What is the 5 tuple notation? Set of state, input alphabet, transition function, initial state, a set of final state. So what is a Q? What are the states? Q0, Q1, Q2 and QF. What is the input alphabet? 0, 1. What is the initial state? Q0 only. What is the final states? QF only. Right? Now, what are the transitions? Q0 on 0 going to Q1. Q0 on 1 going to Q0 only. Q1 on 0 goes to Q1 only. Q1 on 1 goes to Q2 only. Q2 on 0 goes to QF only. Q2 on 1 going to Q0. QF on 0 QF only. QF on 1 is a QF only. Right? So we represented in the 5 tuple notation. So what is the next? Transition diagram. Input symbols 0, 1 are the columns. Then states Q0, Q1, Q2, QF. What is a QF? A final state. We represent with a star. Now Q0 on 0, where it goes? It's a Q1. On 1, where it goes? It's a Q0. Then Q1 on 0 is Q1 only. Q1 on 1 is a Q2. Q2 on 0. What is a Q2 on 0? It's a QF. But Q2 on 1 is Q0. QF on 0, it's a QF only. QF on 1 is a QF. Right? That is a transition diagram. So we have seen some examples for deterministic finite automata, which already are known from in the finite automata theory of computation. So in the next class we'll continue with the non-deterministic finite automata definition, and we revise some examples. Right? So for today I'm closing the section. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.